Hi everybody on the internet and here. My name is Jay Zalowitz. I used to be an engineer over at a company called Capital One, which is probably in the top 20 in the world in terms of AWS bills. So it just kind of ended up becoming my job to make that not in the top 20, but it keeps growing. And they're still there. But in the meantime, I think we saved between like $50 and $75 million a year. So here are some tips and tricks I learned for both that, personally helping a whole bunch of people, yada, 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 that could be potentially useful to you. Now, I will start out with the formal intro slide. I live in San Francisco, not Seattle. Apparently, we both have a lot of clouds, a lot of cold weather, and a lot of nerds. I work in the travel industry, which is great because I used to, live in a hotel basically while I was at Capital One. Now I work at a company called Sonder. We rent apartments long-term basically and operate them as nightly hotels or some format of that. We're air quotes reinventing travel. I started Hacker Noon, which some of you might have heard of, with my co-founder David. That's a fun project. I think we're about the 3,000th largest site in the world. I have no idea how that happened. It kind of seems like a blur. My humor is once described as so dry I'd be next in line to direct a Thor movie. If you didn't get that joke, I apologize. It's my fault. Preface. This entire presentation is not going to age well at all. It's just going to be wrong. The style of the presentation is just not going to fit in with future presentations. You see, I view this as it doesn't have any transitional effects. There's not a whole bunch of blazing color everywhere. It's just not going to age well. This may not apply very well to clouds like Oracle. Because I've never actually, anyway, I wouldn't apply to Oracle, wouldn't apply as well to Microsoft, but would probably apply better to that, and would apply less good to GCP as well because they're different demons, per se. Speaking of which, pick literally any cloud. Don't try to pick 3, don't try to pick 2. Don't try to plan as if you're going to move from the cloud you're going to start in. You're not. It's just not going to happen. Quit trying to make multi-cloud happen. It's the fetch of cloud computing. So second preface, consider total cost of ownership when you're doing any of this anyway. What does that mean? Well, if you want to spend a month of developer time to try to save $50, you are not making the right decision. Unless that $50 shows up on somebody else's cost center, in which case you are making the right decision, and that director will hate you forever. All right, up next, in a large company, tag everything about everything, and the entire chain of command that everything belongs to. Start practicing this while you are small, or someone 5 years, that meant to be for now, will look at your EC2 instance and be unsure if they can delete it because they can't access it, and it's making this one call to google.com as a health check every minute. Worse, the code could eventually spiral out of control, and some poor person is on call trying to figure out why a server name, is it about an herb or a pickle, is trying to DDoS Salesforce, and in no way has that happened to me. Oh, you can come in. All right, so I'm going to start breaking down into different services now, and I'll start with EBS. Why? Because EBS tends to be about 15 to 20% of everyone's bill, and like an easy 5 to 10% savings because no one really thinks through it. First thing to know about EBS, and any of the like Microsoft or Google versions of this, they're services and they're not drives. So if you try to raid, come on in. If you try to raid an EBS volume, you are doing it wrong. You've taken something that already has 20% more reliable resiliency, I'm forgetting the exact precise term. It's AFR. It's annual failure rate. They have 1/20th of the annual failure rate on EBS compared to a normal drive. And then you're doing it to where it's going to not fail another about 1/20th. Just don't try to raid EBS. It's a bad idea. It just slows things down. It's not worth it. So do know that everything is a service within that. Oh, sorry, one back. Do know that everything is a service within that, and to treat it like that, and to stop thinking of it as a drive and start thinking of it of a throttle up or down on something else, depending on what type of thing you're working on. Next. All right, so you're almost positively doing EBS wrong, part one. Throughput is determined entirely by volume size on a GP2 drive. IO1 drives, which are provisioned IOPS, are the devil. They're the worst things you've ever heard of. There's no point to using them. It's literally, I've seen about 1,500 teams at this point in my career, and I've seen exactly 3 valid times that needed IO1 drives, and 2 of them are no longer valid after they released a managed Cassandra. So like, don't use an IO1 drive. How bad is it? It's literally double the cost to use an IO1 drive to get the exact same performance. The only reason you could want to use an IO1 drive is if your networking somehow either has to be above 25 megabits a second to the drive, 250 megabits a second to the drive, and it needs over 16,000 IOPS, or if it needs to be over, I want to say 32,000. I'll get to that part, but there's basically no system where you can't just spread it across multiple EBS volumes and it won't work just fine. Do know that on any size drive, you're automatically getting 3,000 burst bucket. The quote from Amazon is that the number of people who have ever exhausted the burst bucket for these drives is in the, like, I want to say 0.1 territory of accounts. You're just not really going to hit it anyway, so just use multiple small drives, which, by the way, is a theme here. If you can choose an instance and you're not paying for things like Datadog or other things on a per instance basis, always go more smaller things. And I'll get to why later, but that's just going to be a running theme. Next. So the cheaper drives do better networking anyway. You can literally just hop to an ST1 or an SC1 and pay, I think it's 1/10 of the price. It's the EBS is where almost everyone is wrong about their cloud sizing. And it gets even better when they're doing it on RDSs, because they'll just choose a 100 gigabyte drive and it'll sit there forever and you'll use 1% of it. On RDS, you have auto scaling drives, which means you can set it to 8 gigs and start loading things up and you're good. Does anyone here know how many times you can actually just increase an EBS volume on the fly without interrupting things a day? You could do it every 8 hours. And the only reason it's every 8 hours is they don't want a whole bunch of people expanding a whole bunch of drives in some sort of runaway event. You can literally just pick it small and update and grow it as you need. Do yourself a favor and look at your EBS volume use first, because it's the easiest one to convince everyone to do. It's pure numbers. They don't have to guess, and you can fix it every 8 hours. Let's go to the... so I'm going to get into the EC2 part of this conversation. And I'm going to start it with, even if you choose the right instance for your workload, and your app does not change, you are still going to be wrong in 18 months due to Moore's law and growth in RAM. Like, the way Amazon has just continued to do it, they keep releasing something new, and the work that you will try to convince a very large corporation to get on a newer instance type will all be wasted because, well, it's outdated. But that being said, always go for the most recent instance type. The 3rd generation to the 5th generation costs 40% less to be at the 5th generation, and you get, in some cases, 10 to 20 times the throughput on different parts of what you're using. So if you can choose the latest instance generation and your software doesn't prevent you from doing that, always go for the latest. A side note is with Nitro, and back to the more smaller things, a large and a 2XL, so like you're paying 4 times as much, have the exact same networking throughput. So if you want to serve a heck of a lot of traffic and your app can fit on a large, which is I think 8 gigs on an M, just spin up a whole bunch of instances and serve all the traffic that way. Don't go out of your way to try to like provision a massive box that doesn't scale up or down. If you view it as a big tidal wave thing, the entire purpose of auto-scaling is you can go up or down. If you have, I don't know, like an Empire State Building tall instance on that graph, you don't really scale it. It just sits there the entire time. Take advantage of your auto-scaling and actually use small instances and get more throughput for free. Yeah. I actually got ahead of that one. Yeah, one more. All right. So this is the part where I break down into a graph. Is this a graph? Is this a? Yeah, I've done it. So if there's one thing I can express to you guys when trying to right size all of your instances that you're actually working with is this. If you view this, like, does anyone here use AWS a heck of a lot, I guess, as a preface? So let's say I said that this meant middle. What do you think the C stands for having more of? CPU? What do you think the R stands for? Yes. And ignore this because it's extra. Did not plan that joke, but it worked. So here's the thing. Even within the same instance family, you can move to the left or right on this chart, and for the exact same price, handle more workloads. If you're over in container land, odds are you want something over here. If you're doing some map reducing process, odds are that's better. And what's even funnier is if you're swapping things in and out of RAM, like low-level RAM, like your L3 cache or anything really, really deep in the internals of your system are getting overwhelmed, going to the C or Z instance types, which are the compute-heavy ones, are using faster sets of processors for that exact activity. So even though it may make more sense to have RAM in a MapReduce cluster, check out the C instance type. Now, it's purposefully, so this didn't age badly, I left out the actual generation, but you should always stick with the 5th generation there unless 6 ends up working out really well for everyone, which I haven't heard great things. All right. Here's the part where I try to explain. Go ahead. Sorry. Yeah. Here's where I try to explain everything with a metaphor of something I lived through. So everyone in the olden days used to operate their data centers a lot like a very large hotel that kept a room open just for one person, always in case they decided to spend the night. If you bought a data center, if you bought colo space, you kept that there no matter what. And you couldn't really shift it around that easily. It's gotten better since then, but on-prem still tends to operate like that with a lot of companies just because there's a whole bunch of overhead. When AWS came along, when GCP, Oracle, and and Microsoft came along with their clouds, they made that a programmatic thing. So you can swap those things in and out, and you can start scaling your infrastructure against what everyone else would be using. So you're operating a normal hotel, right? But you're still keeping those hotels open for an incredibly long period of time, and your reaction speed's really low. When you start getting into containers, you start talking about having a really efficient cleaning staff that can get through things and open it up and make it available to everyone. Instead of having a couple minutes to boot up an instance, you're talking about seconds within your spare capacity. And when you get to serverless, you're operating, what is the nicest way of saying this? Maybe a hotel of disrepute where people rent by the hour, but you're totally okay with that because you're built for that, and you can handle whatever capacity demands that are actually needed. There's nothing wrong with that hotel. It fits a lot of workloads, but you have to decide if that workload is for you. Next. So that brings me to a big point about containers. If you're requesting space in a cluster, it is the exact same thing as requesting an instance on EC2 or whatever your provider of choice's version of that is. If it doesn't need to be a really large container, don't have a really large container on there. If you can use Alpine, you can double the amount of things you have a lot of the time on a given cluster. So instead of having an Ubuntu base, just build exactly what you need to be on those containers. Build those into the container. You can build containers in stages. And literally, for example, if you're using Go, all you have to do is have the Go binary on there and just run the Go app. So you can take a lot of Teams, 1.5 gig container requirements and take it down to 50 to 500 megabytes. And that means you're tripling the effectiveness of that containerized cluster. So especially for those companies that are really into containers, have a look at that. Start considering having base containers and start building off of those base containers in a structurally well done way, and you'll end up saving a lot of money. In some large companies I may or may not know of, that number was in the tens of millions of dollars. So and I wasn't talking about Capital One. Seriously, no, it was not. So please make sure you look at that. This isn't really a big serverless talk, but if you are building something serverless, remember that you're building a very atomical thing that can run and scale at will. If you can reuse that, you're going to save a lot of time on your total cost of ownership. So if you provide that microservice, a literal microservice, those can be invoked by dozens of different things. And if you invoke it by dozens of different things and you've scaled that all properly, you grow as a company much quicker. If you don't spend your time on that and you build one big Lambda that responds end to end on everything, it's not actually providing any real benefits of being serverless. And I will say that as a specific thing, the gigantic and real benefit of serverless is actually engineering time and not cloud cost, because oftentimes it can meet or exceed. So please make sure you build atomic serverless elements. All right, now on to another set of jokes. You are almost entirely wrong about managed service sizing. I already kind of covered the RDS drives, but I'm going to drill this in. There is a checkbox, checkbox you can click on AWS that says automatically expand my drives. You check that box, and you will never run out of space. So just start with a really small drive and then grow it. Just quit spending millions of dollars on that. That's a bad idea. The reverse is probably true for DynamoDB. They scale to quintillions of events. You're good. The total cost of ownership on Dynamo beats the hell out of a lot of things, and master databases tend to work a lot better. But I'm going to stop for a second and say one thing. Route 53 is the single greatest database ever. And I don't know how many of you actually know what Route 53 is, so I will define it because this is great. Route 53 is AWS's DNS service. Now, I know what you're thinking. Jay, DNS is not a database. Yes, DNS is exactly a database. If you literally just encrypt the text you need, there is a text field type of entry in Route 53, and you can store in a globally resilient system that will get sharded across, and not even sharded is the wrong word for this, distributed across multiple nodes, like at least 53. Just saying, it will be stored in at least 53 locations. Exactly what you want, as long as you don't care about the write time, and you don't even have to care about the write time because you can just have a next pointer and treat it like a blockchain. So yes, that's right. I've managed to work blockchain into a talk about AWS, which no one should ever do, ever. But Route 53, kind of joking, simultaneously the cheapest database, way cheaper than Dynamo, simultaneously the most resilient database, way more resilient. It sounds crazy. Consider Route 53 for your database. Silly. But if you want to know more, there's a link. We'll share this online. So on the helpful links, ec2instance.info is a really great lookup tool to actually find out where you're, like what instance you should be going to. Just go to your Datadog, whatever, find out where your top lines are, set that as your maximums, and you'll be able to find the cheapest one just by literally drop down. You don't even have to have an index knowledge, you just have to be able to say, like, what am I using at peak? And then add like 20 or 30%, and you're gonna be fine. Side note that I didn't really get to anyway, if you are on the JVM, you are going to use the maximum amount of RAM possible, which is totally fine. But if you're trying to add an excess 50% capacity to a JVM app, you're doing it wrong. It's never going to happen. The JVM is the worst memory hog on the planet in a kind of good way. Cloud Custodian is what we use at Capital One. Basically, if you need to send an alert, a message, anything, shut things down when they're not in use, clean things up, it's a really good option. The serverless framework, if you really just want to bang out a bunch of YAML and have an app running pretty much instantaneously, is probably the fastest version of that. That's when you're working on your own or when you're working in a small group. If you have to work with things in a very large company, totally not biased here, you should check out T-Mobile's Jazz. They have deep integrations on a lot of different parts of it, help with the CI/CD part. Yeah, it depends on where you are on your journey, and frankly, if you're gonna have a bunch of executives ask you a hell of a lot of questions, like, does it do this? Yes. Does it do that? Yes. That one's that. The other one's go do something in a startup. You could try that in a startup, but half the benefits just aren't. Total cost of ownership. And my Twitter is my name. My Instagram's my name. My Facebook's my name. My GitHub's my name. My MySpace is Jay-Z. I'm not kidding. Don't ask me how that happened. I know Tom. All right. So yeah, go ahead.
Oh, thank you.
No. Hit the next button.
Oh, there's another button?
Yeah. No, thank you for having me by. This is a really cool space. And have you seen the background behind me? It's cool. I know I've been talking for a bit, and I know everyone kind of wants another beer, but are there any questions?
Could you tell a bit more about Route 53? Are you actually using it as a database at Sonder?
We are not using it as a database at Sonder because we're actively just transitioning to a new cloud provider, and that's taking up most of our time. But I am actively looking for a place to use this, and I think I might just come up with a joking database framework purely to pull this off, because it is literally the cheapest and simultaneously best as long as you don't need things to go I/O really quick and you don't need relations inside of your database that you need to compute by the database instead of on your computer.
Okay. And I'm thinking of two questions, but I'll ask you about Cloud Custodian, if I can. You were talking a little bit about it. It sounds like a monitoring tool. Could you tell us a little more what it would do for the cost optimization?
Yeah, so Cloud Custodian is what we call a policy as code tool. If you want to, ideally anything you do on the cloud should be written as code first. Your infrastructure should be declared as code, your policies should be declared as code, your identity and access management code. What we, at Capital One, we have a heavy compliance burden, as many other people maybe on the live stream have. And as such, enforcing rules and being able to report back to a regulator that we are enforcing rules is very important. But since we already have the ability to, for example, send a direct email, which, by the way, go back like 30 different things to that one really long slide. You're almost there. There. I'm not kidding. Tag everything. If you have a owner contact and you have a owned application group, and that application group has a reporting chain where it has to have a person, you will be able to get somebody to do something. Trust me, it is not a lot of fun joining a company where you don't know automatically who owns something. It is insane, it is crazy, and you'll spend at least 3 weeks inside of Asana trying to figure that out, probably longer. And eventually you'll just be like, can I cut this off? And then you'll find some guy named Craig that owns, this data store that you're like, why is this even here? Well, it's data from 2016, but we have no other place to run it. And I'm like, okay, great. As long as I know who it belongs to. Like, can I turn it down a little? You don't need a $40,000 a year RDS for one access every week.
Another question, can I?
Yeah, go for it.
So the other question is, when, let's say, maybe you've had this experience before. Let's say you're on the cloud team within the company, and you need to now you're tagging stuff, but you haven't been. Do you guys have you seen a practice where you charge different teams within the organization for the service that you provide as a cloud team for like onboarding, intake, and like just supporting their journey and providing all of that?
It's kind of a hard chargeback model to do for anything. Where chargebacks actually get really super complicated and a little better is than like directly giving them as a service, because you can't really view it like that. When you make things better for developers, you save the company money, and you need to convince the executives that the money being saved by employee time far outstrips things, because the right answer tends to be develop more features, not save money, unless your company is severely financially constrained. And I know I'm saying this in the middle of a viral outbreak that's causing what might be a bad recession, but at least airplane fares are cheap, so that's nice. Sorry.
So are you saying you wouldn't charge back the team?
Don't charge them for the work. Charge them for the server costs and getting them on the containers. So you ideally want them using the least footprint as possible and auto scaling much more quickly.
Okay, so what you're saying is, let's say AWS is charging me, let's say $10 for an EC2. Are we charging $10 for EC2? We're not adding on anything, right?
Well, so AWS is charging you 10. So go back to, I think. Yeah, one slide. AWS is charging you $10.
Right.
Datadog's going to charge you 7 to 25. I have no idea what they charge, or whatever version of that you're doing. The logging you're using is 10 cents a gig, I want to say, if you're keeping it for only 7 days.
You do it on serverless.
Serverless still has logs, but I get your point. Then you're, and some of those costs still remain. You have somebody who has to stay on call, depending on how you built it. You have your security auditing firm that costs you a lot, depending on what company you are. Then you have your actual security updating team. Those people cost a lot of money. Your updates aren't automatic because you don't know whether or not your code's going to end up breaking when you update something. So you have to give people a whole bunch of time, whereas you could have just had end-to-end testing and stage deploys on a whole bunch of containers. So you have a base container, and then you build Alpine Linux with Node on it. You build all the rest of those down, and then you test as if you're building an artifact all the way down. And you've saved years of man hours, depending on how big the company is, instead of having everyone host on an EC2. So that $20 EC2 cost could end up costing you somewhere around $1 million, depending on how many people you throw in on it. So I'd much rather focus on providing them a product that costs a lot less in total cost of ownership than having an absolute amount of perfect savings. But what you'll find out if you try it hard enough is building a system that works like that tends to be an auto-scaling, security, resilient, fully tested, fully monitored system that ends up being the cheapest way you can do it anyway. What's up?
Is there any way we can enforce tagging your resources in AWS?
Boy, can you! First off, AWS actually has, I want to say guard tower or sentinel or some ominous sounding thing that can enforce tagging on its own. They have their own managed policy as code thing. There's something called PackBot, once again by T-Mobile. There's a cloud custodian can do that out of the box. You can literally, if you do nothing else, then go back to your company and try to convince them that they have to tag everything and show them that this is easy. Some executive someday is going to love you, because the easiest way to tell how much an app costs is by breaking it down by tag. So you don't have to do anything else other than walk over to the version of the CFO for your group and just say, you know the budget and how you wanted to blame it on somebody? And charge back on that one service you did. Tag things. Can we make sure everyone tags? That's it. And then suddenly there'll be an edict from on the CEO level, and yeah, we're tagging everything now, and you'll be great. I now know who to contact in case Jenny has taken down Google again.
Another question. Is there any services exist in AWS that can help us to monitor or send some emails if there's a threshold that we go beyond some number of dollars?
So there is both a specific one to billing and which I think it's Trusted Advisor. And then you can fire a CloudWatch event and basically send emails from there.
There's also a service, right, that they offer that is supposed to try to find efficiencies and kind
It sucks.
Right?
And I'm on camera. It sucks.
Right, because why it's a conflict of your own interest.
Just to be very clear to the internet, that really is the worst thing.
What's the name of the service?
I'm forgetting. And I talked to the team, and I love the team. The team is great people. But AWS has this one really big problem, and it's we don't want to operate in user space. They have the exact same problem that Linux does. which is, I mean, I totally get the Linux kernel for doing this, but AWS owns enough shit anyway. This doesn't make any sense. They're like, we don't want to run things on top of your EC2 instances. So they don't know your RAM utilization at all, like zero. They just don't know, which is hilarious, because if any of you have ever used ECS, the container system, they are monitoring RAM there. They have something called ECS agent. So it's there, and it's available, and it has a RAM, and it has a RAM utilization, and they refuse to build this into any of their tools. They don't want to do, they're like, they have like a Datadog competitor, a New Relic competitor, all the rest of that shit, like a shitty one, don't get me wrong, but like they have a competitor to this that could monitor all your stuff for really cheap, and it's native with AWS, and it's really easy to use. And they're like, nah, we just want to use that on ECS. Like, just drop the ECS bit and call it agent, and then monitor RAM and tell people what size to do. Better yet, have it set automatically on your auto-scaling group. Like, literally, I don't care. I do not care. Choose my instance type, auto-scale for me, I'm done. Like, manage my shit. I don't care, Amazon, you are smarter than me. You are led by a big-headed alien. I'm not sure about that last statement. I don't know if I'm allowed to say that. Please don't hurt me, Jeff. No, he's great. He's a great guy. He's doing things for space. He's very philanthropic. Yeah. Anyway, I wouldn't use that. There's a bunch of really great companies that haven't quite found product market fit that are doing versions of that. At Capital One, we literally built our own that just harvested our own Datadog and used our tagging system to send out, hey, quit doing this, move to this instance type, and you'll save $100,000. And then we CC'd their VP, and then suddenly people did things. So if you learned any lesson from this talk, it's tag everything and then CC the VP.
Thank you.
Thanks, guys.